Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to have a look at graphing functions. This is a follow-on lesson from the video I did on functions, so if there's anything from the start here today that you are not sure of or you think you need to brush up on, I've put a link to my other video on functions in the description, so I would recommend, if there's anything that you're unsure of, pausing this video, clicking on that one, watching it and then resuming right here. So where we finished up on in our last video was here, and more specifically this box here, my box on linear functions and quadratic functions, which are the most popular ones that come up in your exams. Just in order that we're okay for today's class, I've put in a box here about exponential functions as well. It's something that we've touched on in our last lesson, but it's coming up in an exam question today, so just a couple of things to be aware of for exponential functions. For an exponential function, our exponent is the thing that changes, so it's going to be something like a to the power of x, where a is your number that you are given and x is the thing that changes. So in your junior cert, they will ask you, it's usually 2 to the power of x or 3 to the power of x, where your 2 or your 3 does not change, but your power does. So you'll be dealing with 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, etc., depending on what they're telling you to substitute in for your x value. We're going to have a look at what those look like once we get to our exam question, but as I said here, your exponent changes, and just 2 points about where it crosses your x and your y axis, because that's what we had to look at for our linear functions and our quadratic functions as well. This is going to cross the y axis when x is 0, and we'll look more into that in a minute or two, and it does not cross the x axis, so we'll have a real in-depth look into that and why that is. It's actually quite interesting. The question we're going to be having a look at today is 2017 question 13. There's 3 graphs and they all relate back to our linear functions, our quadratic functions and our exponential functions. So just to repeat myself, if there's anything on this page here that you are unsure of, I would advise you pausing this video and having a look at my other one. I suppose just excluding your exponential functions, because I'm going to be talking about that as we get onto that part of the question. All your key points here that I have on this slide, I'm going to copy and paste them into the description of this video so that you can copy and paste them then into your own notes. So just keep an eye out for those as well. Okay, 2017 question 13 asked us to draw each of the following 3 functions in the domain -2 is less than or equal to x, and x is less than or equal to 2 for all x is an element of R. And I find even before people look at the functions here, they get tripped up on that very first part. So I'm just going to spend maybe a minute talking through each of what the actual words here mean and what this will mean for future questions as well. If we know what this question means, then it'll make our life a whole lot easier for future functions questions as well. First word, draw, we all know what that means. It means you're going to have to represent your findings in a picture. So you're going to have something like that, that, and that. You're going to have to draw something. So in this case, it's a graph, and it's going to look something like what I've drawn here. Now, we're going to be trying to be a small bit more exact than the scribbles that I've drawn, but you should have something written on your graphs by the end of this question. That's the point I was trying to get across there. Each of the following 3 functions, well, let's find out where they are. My first function is y is equal to x minus 1. My second is y is equal to 2 minus x squared. And my third one is y is equal to 2 to the power of x. Okay, so I know I have to graph this one here, this one here, and this one here. Okay. So I've gotten through the first couple of words. Now the last part here is where people get a small bit confused. The maths terminology comes into it and the maths notation as well, but let's try and break this down. The domain is just a fancy word for all your x values. And I'm just going to write that in red just up above here. It's just your x values. And it tells you a bit more information here about your x values. It says that they want your x to be less than or equal to 2, but greater than or equal to -2. Basically what they're telling you is that they want all your x values to be in between -2 and 2. And they give you another piece of information. They say that they want x to be your real numbers, an element of R, meaning your real numbers. If you recall, your real numbers are your positive numbers, your negative numbers, your decimals, your fractions, your recurrent decimals, basically any number that you can think of at the moment. Are the opposite to real numbers. Now, the next part that I'm going to say is not on your junior cert course, it's leaving cert stuff, but if you were interested, the opposite of real numbers are imaginary numbers, and you'll have a look at those in 5th year and 6th year. For now, we're just dealing with the numbers that we know of, and if you look at the empty graphs that they're after giving you, they've told you here in writing, and I'll just highlight it again for you, that they want your x to be in between -2 and +2. They've done that on each of the graphs for you. They've started their x-axis at -2 and they finished it up at 2. So they've actually helped you out. So they've given you the question in English, but then they've sort of set it out for you mathematically, and all you have to do is fill in what this function here will look like on this exact graph. So they're actually very nice to you in this question. Okay, there's 3 functions to get through. We know certain pieces of information from these straight away. We know that my first one is going to be linear because the highest power of x is 1. We know that it's going to go upwards because the number before my x, well, this is y is equal to x minus 1, but the number before my x, or my coefficient of x here, is 1. They don't usually write that in our questions because as mathematicians we try and write things as short as possible. So x is the same thing as 1x, but it's far easier to write just x on its own rather than 1x because you've one less thing to write, and literally that's all there is to that. For our question here, it was handy to put in the 1 in front of the x just so I knew exactly what was going on, and just to make sure in my own head that I know that the number in front of my x here is 1, and I know that it's plus 1 to give it its full name, and that's going to indicate that my graph is going to go upwards. So I'm going to take that bit away there. One more piece of information, my -1 here. I know that my graph is going to cross the y-axis at -1, going on what we said earlier. So I'm just going to put that point in, and that point is right there on the y-axis. It's going to cross it at -1. So I know that already. So from what we've looked at before, we know those 2 pieces of information. I know that my graph is going to go up, and I know that it's going to cross the y-axis at -1. For my second graph, you've got y is equal to 2 minus x squared, and I know that that's going to be quadratic. And you know this because of the x squared. There's no other higher power of x. It's x to the power of 2, which means it's going to be quadratic. Now for quadratics, it's not going to be a straight line. It's going to be a curve, and it's either going to be a curve like this or like this, and you've got to decide which one. The minus here gives you a big clue as to which one it's going to be. If you remember, if it was a positive x squared, it would be a happy face. If it was a negative x squared, it would be a frowny face. So we know that this is a negative x squared because it tells us in the question. So we know that our graph is going to be a frowny face like that, and we also know it's going to cross the y-axis at y is equal to 2 because 2 is the constant here. Now I know this is written, we were used to writing our quadratics as y is equal to x squared. This is just an example now, x squared plus 7x plus 10. And we were used to our constant being on its own at the end here. However, they've mixed it up here to see how would you deal with it. we need to just be sure that we know what our constant is. It's the thing not attached to the x, and in our question here, they've put it at the front of their equation. So just be careful of that. I'm going to take this away just so you don't get confused. That was just there for my demonstration, I suppose. Okay, for my last one here, this is the one we haven't really had a look at, but I'll give you a spoiler alert as to what it's going to, or not a spoiler alert, a spoiler as to what it's going to look like. And then when we do our actual question with this exponential, we'll compare it back to our notes here. So we know that this is going to be exponential, because it's y is equal to 2 to the power of x, and my x is going to change. So if you have your calculator on you, if you started substituting in values like 2 to the power of something, you'll notice that if you put in small numbers in here, like your answers will more or less be quite small. But as you start raising your numbers, so if you put 2 to the power of 5, 6, 7, 8, 9, 10, your numbers will get bigger and bigger, but they'll get bigger like quite quickly. So if we were to graph that, your graph is going to start off quite slow, but then it's going to go up pretty quickly, like that. So nothing to do with maths, but I have one smiley face in the middle here. I'm going to fill in my other 3 here just because, and now my quadratic equation has 2 friends. Okay, you don't need to do that in the exam. I just saw a face here and I decided to draw 2 more. Alright, let's have a closer look at my linear graph up here. We know what it's going to look like, but let's see exactly where on the graph it's going to go. So I'm just going to do that a bit bigger here. This is the first part of your question. And for a linear graph, if you think about it, a straight line, I have on my straight line, I want, this is made up of a series of points. We want to find the minimum amount of points possible because we want to make this easy on ourselves. So the minimum amount of points you need in order to draw a straight line is 2 points. So let's say I pick this point here and this point here, and I drew a straight line through those 2 points. I would end up with that straight line. If someone else came along and took this point here and this point here and drew a straight line through that, they would end up with the exact same straight line. So it doesn't matter what 2 points you find on your line, as long as you find 2 points. So we need to find out 2 points that go in here. In other words, we need to find out 2 values of x and y. So I'm substituting in numbers in for x and y so that they work for that equation. So I need y to be some number minus 1. Now, you can substitute in any numbers that you want. However, there's 2 numbers that are a whole lot easier than the other. And just to take a small break now from this question, now would be a great time to take a break, is what I should have said. We're going to have a look at the x and y axis. And we're going to look at 2 facts from those, and we're going to come straight back to this question and try and apply it to this question so that we can do this type of question in an exam as easily as possible and get our marks without any fuss. So we're going to just look at our x and y axis now, and then we'll be right back to find out 2 points on this equation. Alright, my x and y axis. I've drawn an empty coordinate grid here, and just up at the top here I have my question here, just so I'm on track. For my x-axis, it's the one going horizontally, and I've labeled it here my x-axis. If I was to label the points here that I've done in red, points are made up of an x part and a y part. So I'm going to fill in these points here. This point right here, the first one, is across 1 and up 0, so it's going to be 1, 0. So that's my x part and my y part. This one here is going to be 2, 0. This one here is going to be 3, 0. This one here is going to be 4, 0. This one here is going to be 5, 0. And I hope you can see the pattern there. No matter where I go, like I can go into the negatives on my x-axis as well. Like if I took this point here, for example, this would be minus 3, 0. The point here that I'm trying to make, and I'm just going to get my highlighter, is that on my x-axis, all the y parts of my point is 0. So over here, on the x-axis, y is equal to 0. And they're very fond in your exam of asking you about the x-axis and sometimes the y-axis in a question. If you didn't know that on the x-axis your y part of your point is going to be 0, if you didn't know that, you would be in trouble with your question. It would take you that bit longer to do it. So this right here is a really important fact, and I'm going to put this as part of my key points in the description, so keep an eye on that. One more point, one more piece of information that I'm going to give you is something about the y-axis, and you might see where I'm going to go with this. I'm going to get my yellow. This point up here at the top is going to be 0, 4. This point here is going to be 0, 3. This point here is going to be 0, 2. I'm going to skip a couple of the points here because otherwise I'm going to run into what I've written from my x-axis. This point here is going to be 0, minus 1. This point here is going to be 0, minus 2, and so on. You will notice that on the y-axis, all the x part of my points, and I'll get my highlighter again, all the x part of my points are 0. So if I was to draw that in here, on the y-axis, the x is always equal to 0. So it's sort of like opposites, I suppose. On the y-axis, your x is 0. On the x-axis, your y is 0. And I cannot highlight those two facts enough. Okay. Now, this is very important for questions, as I said, in your exam, but it's also important when you're trying to find 2 points on on the function of a line, which, if you remember, is the whole reason we were talking about our x and y axis. This is the question that we were having a look at. We're going to use the 2 facts that we used previous to find out where this crosses the x and y axis. So if you remember, on my x-axis, my y is equal to 0. So what I'm going to do is I'm going to use this fact here. I have this fact here. I'm going to use this, combine it with my function up here. So my function, I know that my function says that y is equal to x minus 1. But I'm going to see what happens when I take out the y in my function and put in 0. So instead of saying y is equal to x minus 1, I'm going to say 0 is equal to x minus 1. And if I was to solve this equation that I have now, if I add 1 to both sides, so plus 1, what I'm going to end up with over here is that x is equal to 1. Now remember, we wanted to draw each of the functions here on my graph. Graphs are made by points. I have the x part of my point, I have the y part of my point. The x part of my point is 1, the y part is 0. Right now you're taking a step from functions here, which are just numbers and constants and x's and y's, and you're drawing a picture of what that looks like. You've got 2 values of 2 numbers. So when x is 1 and y is 0, this equation works out. It makes sense. If you find 2 values of numbers that go into x and go into y, and when they do, this equation makes sense, well, you have a point on that line. So just to point that out to you now, or just to plot that on your point, if I was to draw that, the point 1, 0, I go across 1 and up 0, and that's going to be my first point on my line. However, if you remember, I need 2 points on my line. So I found out where my graph is going to cross my x-axis. Now I'm going to find out where it crosses my y-axis. And you know from what we said previous that my y-axis, on my y-axis, x is equal to 0. So what I'm going to do is, in my function up here, I'm going to take out x and put in 0. So instead of y is equal to x minus 1, I'm going to have y is equal to 0 minus 1. And if I was to simplify that, well, we know that 0 minus 1 is just minus 1. So I'm going to have y is equal to minus 1. So if I was to combine those 2 facts and make them into a point, the x part is 0, the y part is minus 1. On my graph, if I go across 0 and down to minus 1, That is going to be my second point here. Once you have your 2 points, you get your ruler out, and I'm going to get my ruler here, and you join those two together. Once you have that done, let me get rid of my ruler. You have the line, you have your picture of what this function up here, this function here, you have your picture of what that looks like. You'll notice that I've sort of overshot the runway just here and here. Technically that function will go on forever on both sides, but if you remember back to the question, they only wanted to know, well, what's the story in between -2 and 2. So I know I've overshot the runway here. You're not going to lose any marks for that, but they only wanted what was in between, or what the graph looked like in this part of your Cartesian plane. And a Cartesian plane is just a fancy way of saying the empty xy plane that we're after drawing out here. So that's our first question done. That's linear functions, how to graph them, get where your graph crosses your x-axis, get where it crosses your y-axis, get your 2 points, join them. That's your question done. Okay, the second part of that question was a quadratic question, and basically in this one here, 2 points isn't going to cut it, because if you think about it, our graph is going to be this shape. So there's a couple of, if I've 2 points isn't enough, I'm going to need to find more than that so that I know where the curve is going. So for a quadratic curve, it's a slightly different way about going about that question. We're going to draw a table out to try and find out 5 points off that curve. We want to find out what the story is with y when x is -2, when x is -1, when x is 0, when x is 1, and when x is 2. So here's a table that I've drawn, that I prepared earlier on that question, and I've my question up here in the top right as well, just to keep me on track. I've done it into a couple of different segments. I have my domain here, so all my different values of x, and I'm going to fill that in right now. So all my different values of x, if you think about your x-axis here and what your question asked you about what your x's actually were, it started off at -2, -1, 0, 1, and 2. I took all my whole numbers between -2 and 2, and this is going to help me find 5 points on my graph, which is loads. My middle part here that I've done in orange is my function, and that's equal to my y. So if you remember up here, y is equal to 2 minus x squared. Well, 2 minus x squared, that's the thing that I'm worried about in this question. When I find out what 2 minus x squared is for all of these different scenarios here, I'm going to get a value for y. And once I find out what each of my values for y is, I'm going to end up with 5 points, and then it's just a matter of plotting them on the graph. So let's get cracking. I'm going to take my first row first, when my domain, when x is equal to -2. So x is equal to -2. So I'm just taking my first line here, and I'm just going to do that. I'm just going to highlight that just so we're 100% clear. Oh, that highlighter sort of disappeared when I went through my functions thing, but I hope you can make that out. I'm just taking this part here, and we're going to concentrate on this, and then we're going to see if there's any pattern that emerges for the rest of those. But I'm just going to show you where the numbers here come from first. So when x is equal to -2, I need to substitute that fact into my function. Now remember, my function said that y is equal to 2 minus x squared. So what I'm doing is I'm taking out my x here, and I'm putting in -2. Now this is quite a tricky one, because we've got the minus from our function here, and we've also got the minus from our -2 that we're substituting into our function. So just be careful. Y is equal to 2. I'm substituting this in now. So y is equal to 2 minus. This minus is part of the function, so that's going to stay where it is. Now I'm taking out my x, and I'm putting in -2. So in order to protect that, I'm going to put it in brackets. And the reason I'm putting it in brackets is we want to square all of whatever x is. We want to square all of minus 2. We don't want to just square the 2 part of that. If you put this into your calculator now, the proper way of doing it, we're going to get y is equal to 2 minus. Now if you think about it, minus 2 squared is minus 2 times minus 2, which will give you plus 4. So this part here is plus 4. And I'm going to keep that in my brackets, plus 4. And if I was to work that out now with the rest of my equation, I have 2 minus plus 4. I have minus multiplied by a plus here. So that's going to end up being a minus. So it's going to end up being 2 minus 4. And my y is going to end up being minus 2. This is the correct way of doing it. So my point here is going to be, my x is minus 2, my y is minus 2. So my point here is going to be minus 2, minus 2. Just be careful up here. And I'll just get my highlighter out. Apologies there, my screen just went berserk. Where was I? Oh, here. Just be careful on that part there. If you are substituting something in, I will always bring my brackets with me, because if you don't bring your brackets with you or protect what you're substituting in with brackets, you'll end up with something like this. I'm just going to write down here at the bottom. You're going to end up with 2 minus minus 2 squared. And for this part here, your calculator is going to read that as, like, your calculator follows BirdMass or BOMDAS or whichever version of your order of operations that you use. It's going to read this part here as 2 squared first. It's going to do your indices part first. So 2 squared is 4. Then it's going to slap a minus sign onto that, so minus 4. And you're going to end up with 2 minus minus 4. Now, if you have a minus and a minus being multiplied by each other here, you're going to end up with 2 plus 4 there, which will be 6, which is the wrong answer. So just be so careful on this step here when you're substituting in. Just be so careful that you put your brackets there. So I'm going to take this part here at the bottom away, because I don't want you getting confused about that. Okay, so we want to, you could do this for each one of your points here. I've done it for minus 2, and I've done my equation out, and I found out what my point is. But drawing my table out keeps myself a lot more organized, and if you do make a mistake, you can easily see where it actually is. So I'm going to get my black pen, and I'm going to fill in what we have here. For this, if I was to just fill in what I've done here, just fill it into my table on my first line here, the one that I've highlighted. If my domain, if x is minus 2, and I'm substituting it into this function here, I'm going to end up with 2 minus minus 2, 2 minus minus 2 squared. This 2 here, you'll notice, it doesn't have an x attached to it. It's my constant. So this right here isn't going to change. Like, even if I was substituting in x being like 1,000,000, the only thing that would be changing was my minus x squared, because that right there, it's depending on what the x is. This 2 here, this doesn't care at all. It doesn't have an x attached to it. So that right there is going to stay the same, not only here, but in all of our columns, or in all of my column down here. So I'm just going to fill that in. Right here, minus minus 2 squared. As we see, this part here, minus 2 squared would give me 4. So this right here would give me minus 2 squared. This part just here will give me plus 4. But remember, I have a minus at the end of it. So minus 4. And now, to get my y part here, to get what goes in here, to get what goes in there, and I've accidentally taken away all my highlighter, but you know where I'm going with this. To get my y, it's going to be all of my function added together. So my 2 take away my 4, which is my minus 2, which means that my point here, my x part, and I'm going to get my highlighter back. My x part is minus 2, my x part is minus 2, and my y part is minus 2. So my point here is going to be minus 2, minus 2. And if I draw that just on my small graph up here, minus 2 is going to be there. So that's my first point done. Now we'll go through the next 4 points a small bit quicker. As I said, in my 2 column, my 2's are all going to stay the same because they don't have an x attached to them. They're not dependent on it. So the only thing to worry about is my minus x squared column. So I'm going to do this quite quickly. I'm not going to do my rough work because I've done enough work over here. I hope I've got my point across about what's going on. Minus 1 squared will give me plus 1, but I have a minus 1 at the end, or a minus attached to that x squared. So this is going to be minus 1. 0 squared is 0, and minus 0 squared is going to be 0. Minus 1 squared is going to be minus 1. And minus 2 squared is going to be minus 4. So you'll notice that there's a bit of a pattern here. It's gone minus 4, minus 1, 0, minus 1, minus 4. So that'll often happen in your squared part of your column. There'll be a bit of a pattern. It'll often happen if you have a constant as well. There's a different type of pattern here as well. So your job now is to combine each of the 2 numbers in your orange column to get your y value. So 2 take away 1 is 1. 2 take away 0 is, 2 plus 0. Well, plus 0 take away 0 is going to be the same thing. It's going to give you 2. 2 minus 1 is 1. 2 minus 4 is minus 2. So, filling in my points now, which is what this is all about. This one here is minus 1, 1. This here is 0, 2. This here is 1, 1. And this here is 2 minus 2. And if I was to plot these in on my small graph up here, I've got my minus 2 done. Minus 1, 1 is going to be there. 0, 2 is going to be there. 1, 1 is going to be there. And 2 minus 2 is going to be there. And I'm going to go back to my original question just so we can see exactly what that'll look like. And I'm going to use my red pen. So the points here were, if I remember, let's go back because I forget what they were. Minus 2 is going to go there. Minus 1, 1. Minus 1, 1 is going to go there. And from here I can finish this off. I had the point 0, 2. I had the point 1, 1. And I had the point 2 minus 2. Now you'll notice we said this before, that it's going to be this shape. All we got to do now is finish this off. So what you need to do is join these dots. Now it's not like join the dots like you did in primary school. Remember, this is going to be a curve all the way along. We only have 5 points, so it's not going to be straight lines all the way. You need to do an actual curve. So this bit here is done freehand in your exam. So do the best you can with that. Use a pencil just to be sure. Don't join the dots with a ruler, because if this was a 10-mark question, you would be losing 1 mark for that. You will end up with something like this, which is your, exactly what we said before, our sad face. So for your quadratic equations, a table is the best way to go. And here's the table that I've drawn. Now would probably be a good time just to tell you that there is another way of doing this question using just your calculator, and it's using the table function on your calculator. I will put a link at the bottom in my description for filling out a table using just your calculator, and I'm going to have a talk about that just at the very, very end. But this right here, I suppose the way that I've done this question with a table is maybe the most reliable, as in you have all your work in front of you, but there is a way with your calculator as well. If you just stay tuned to the end of the video, I'll have a talk through that as well, but I just said I'd mention it right now. Okay, that's your quadratic. Last one here, your function y is equal to 2 to the power of x. Again, for this one, like my quadratic, I'm going to use a table because it's not a linear function. So my table is going to look something like this. My domain, my function, function, my y, and then I've got my column for my points at the very end. So again, my domain is going to be -2, -1, 0, 1, 2, and 2 to the power of x. I'm just going to change my color of my pen because otherwise you won't be able to see it on the orange background. So that's going to be 2 to the power of -2. Now if you put that into your calculator, and this bit right here, I'll just put this is going to be old calculator. For the sake of this, I'm going to put this all into my calculator. I will be doing a video on indices, which is powers, in sometime this week, but for now, this bit right here is going to go all into your calculator. So if you go 2 to the power of -2, I'm just going to put what you're actually putting into your calculator. You're going to get 0.25. If you put 2 to the power of -1, you are going to get 0.5. If you put 2 to the power of 0, you're going to get 1. If you put 2 to the power of 1, you're going to get 2. And if you put 2 to the power of 2, you're going to get 4. So what you've done there is you've taken out the x and you've put in all your values for x. So your values for y, seeing as that's your function, it was only one thing, you don't have to add anything onto it or whatever. Your y is just literally what you've done here. So your 0.25, your 0.5, your 1, your 2, and your 4. And your point here is going to be for each of those things that you've subbed in. Let's just fill in. Point here is going to be x is -2 and 0.25. So -2, 0.25. And on the graph, that's going to look, I will do this on the bigger graph in a minute, but it's going to be about there. -1, 0.5. -1, 0.5 is going to be there. 0, 1 is going to be there. 1, 2 is going to be there. And 2, 4 is going to be there. So if I was to do that on my graph, my bigger graph here, just so we can have a proper look at what's going on, my points are going to be there. That was 0.25. This was 0.5. This was 0, 1. This was 1, 2, and this was 2, 4. Now it mightn't be obvious, but that right there is exponential and it is rising it will start rising very quickly after this. Now we were only looking at this graph in between -2 and 2, so it mightn't be that obvious, but if you were to draw a graph like this, and if you were to join all your points, and I better join all my points now before I forget. Remember, this is a curve. We're not using our ruler. We're doing this as best as we can like this. And I've missed that one there, but I'm just going to do my dots a bit bigger so that I nab that. This is only a small part of my graph, so if I did my whole graph, it looks something like this. We've only looked at sort of this part here. So just a small part of the actual graph. Okay. I'm going to now take the 3 parts of my questions that I've done, and we're going to have a look at the marking scheme and how many marks we would have gotten. But just to recap on this part here, for a linear function, you just need 2 points. So get where your graph crosses your x and your y axis and join them. For quadratic equations, you need a table. For exponential functions, you need a table. There is a way of doing exponential functions, quadratic functions, and linear functions just using a calculator. I'm going to talk to you in a minute about that, but we're going to have a look at the marking scheme now for the 3 questions that we actually did. So for my first one here, you'll notice that for this was what they gave us in our marking scheme. You'll notice that they got the 2 points -2, -3, and 2, 1. They still ended up with the exact same graph as us, even though we got 2 different points. So the exact same graph. So I'm going to give myself a tick here. I've gotten the exact same point as those. You'll notice that they've listed their points. And and I've listed my points as well. So even though we've gotten different points, we've gotten the same graph. So I'm getting full marks for that part of my question. For this one here, now I did all my working out on my table, and I'm just after writing in the points that I got from my table. You'll notice that the points that I got from my table for part number 2, which is this one here, they've listed out their points here. I've listed out my points down the way. We have all the same points. I'm just going to tick those off. I have drawn them exactly as the marking scheme has drawn them, so I'm getting my full marks there. For my last one, again, nearly the same as my quadratic. I've listed out all my points. These are the ones that I've taken from my table. In your exam, you would have to show your table or show your workings out. In order to show where you got these points from, unless you're using your calculator, which we'll have a look at in a couple of minutes. So from there, the work we've done in the last 40 minutes will get you your full marks in this question. But now is as good a time as any as to point you towards the link in my description, which is about using your calculator. There is a function on your calculator that will get you any graph, add the points on any graph that you have. But there's a couple of things to be aware of with that. If you are using your calculator, you need to be 100% sure that you know exactly how. You need to practice a couple of questions to make sure that you're getting the right points that are in the marking schemes of the questions that you were doing. If you look at the marking scheme that we had previously, in this part here, and I'll just get my highlighter again. In this part here, it says nothing about drawing a table. It just says about showing your points. So like 2 points correct on graph for your low partial credit, or 1 correct graph, 5 points plotted correctly for all 3 graphs, etc. for your high partial credit. All you need to do is show me 2 points on a graph that's linear, show me all your points on a quadratic, or show me all your points on an exponential function. It doesn't say anything about the table there. The reason I've done the table in the previous questions, so this one for my exponential and this one for my quadratic equation, is because I find it lays out all the work that you've done, and if you have made a mistake, it's easier to see where you've done that and rectify it. That table there will take you about 4 or 5 minutes in an exam. But if you are going to use a calculator to figure out how to do these types of questions, you need to be 100% sure that you're confident of using your calculator to do that. So the video in my description, make sure you're 100% sure on that. And you need to list your points on the exam paper to make sure that you get your marks for that. The pros of using your calculator are it's quicker. And the cons are 1 mistake and you've lost the majority of your marks. If you put like a minus sign in wrong on your calculator, or squared in the wrong place, and you end up with a whole set of wrong points, then that's nearly all your points, or all your marks. That's nearly them all gone. I saw a question, I forget what year it was, but there was 60 marks going for a functions question and the following questions after that. So if you lost 60 marks just because you put something into your calculator wrong, that would be absolutely heartbreaking. So ultimately, this is up to you. The way that I've done in this video is using tables to get your the points of a quadratic equation and an exponential function. But there is a way to do it on your calculator as well. And as I've said about 1,000,000 times, that is in your description. So the key points I'd like you to take from today are: on the x-axis, y is 0. On the y-axis, x is 0. To graph a linear function, 2 points. And if you get where it crosses the x-axis and the y-axis, that's probably the best way to go. For quadratic and exponential functions, using a table to organize your points is required. I suppose I've said required there, and that's not specifically true. If you want to use your calculator, you can. So using a table to organize your points is one way of doing it. I'm not going to write all that up top, but That's one way of doing it. You can use the table function on your calculator, and if you want to do that, as I've said a million times, links in the description. But do make sure you're 100% confident before doing this, and make sure to list your points on the exam that will come out of your calculator. Make sure you list them, and you will get your full marks. Okay, I've been talking for 45 minutes. I think that brings me to a close. If there's anything that I've forgotten here, I think I've gotten all the main points. If there's anything that I've forgotten, I'll put it in the description, so just keep an eye on that. Alright, best of luck. That is it for today.